We're going to start this topic by looking at two fundamental ideas of limits and continuity. To start with, limits are when you have a function, for example x squared minus 9, and you want to know what does this function look like near or as it approaches a point. So near the point x equals 3 in this case, because at this point the function doesn't actually work. Let's try it out. If I try x is equal to 3, I get 3 squared minus 9, and that just simplifies to 0 over 0, which is undefined. So at that point the function doesn't actually exist. As we'll see here, it gets closer from the left, it gets closer and closer to 6. It's very close to 6, and on the right it's very close to 6, but when x equals 3 there's a big hole in our function, so it doesn't actually work there. So we have to find out what is the limit as the function goes towards 3 from both sides, and the answer is 6. That's the value it's approaching. So there's two ways we can do it. The first way is we can try values very close to, but not actually on the value that we're looking for the limit at. For instance, 2.9 on the left will give you a value of the function is equal to 5.9, and if we try 3.1, which is a value slightly bigger than our limit, it'll give you a value of 6.1. So you can see it's approaching the number 6 from both sides, and that's quite important. So here's another example. Here's a graph of a function which at a particular point doesn't have a value, so it's undefined at this point x equals 4. It does have a value, but it's not on the curve. So the function is equal to 3, but the limit as x approaches 4, the value it's heading towards from both sides of that hole is actually negative 2. So we say the limit is negative 2. Right, here's another way of doing it. If we simplify, here's a function and we want to know the value of the function as it approaches negative 2. So you can see as we get closer and closer to negative 2, it's approaching 1.4, but at negative 2 itself, there's that hole, as the function is undefined at that value. So here it is again, undefined, and there's that little hole. So I'm going to simplify this function and see if it will help us find out, can we get that 1.4 as our limit. So I'll factorize the top and the bottom, and there we go, there's our common factor, x plus 2, which I can then just cancel off from the top and the bottom, and that gets rid of this little thing that was causing us to get a divide by 0. That was causing us our undefined function. That was the hole in the function was coming from that. So now I know if I put x is equal to negative 2 in the function, so here's my remaining part of the function I've simplified, that gives me 1.4, which was the limit, because I've simplified it. Right, when does a limit not exist? So here we've got two functions which are piecewise, which means they're kind of two different functions that meet at a point. Well, their domains meet, but they don't actually touch. So the function on the left is going to give you about 2, and the function on the right is going to give you 3. Because they don't have the same value approaching from the left and the right, the limit doesn't exist. Here's a function that just stops. The limit on the left is, let's say the function's heading towards 7, but the limit on, so that's the limit on the left is 7, but the limit on the right, well, we don't know, there is no function on the right. So we say if it doesn't approach the same value from the left and the right, it doesn't exist. Here we've got a function with a bit of a gap, so for the same reason as before, the gap means the limit doesn't exist. Right, see if you can tell me where the function doesn't exist for this function, where the limit doesn't exist. Alright, we're looking for where is this function continuous. So that is to say, imagine you're an infinitely small ant walking along this function. When would you find a hole and fall through it? That's where it's not continuous, because it doesn't continue. So here we are, we walk along here, and at this point we're going to fall through that hole. So at this point x equals to negative 1, the function isn't continuous. Here's another one where you'd fall through, but there's also another rule that is broken here, and that you have to be able to draw this function without lifting your pen off the paper. So I'd have to jump up here to continue drawing my function. So for that reason also, this function is not continuous just here.